Oh, there we go, maybe. Oh, okay. Okay, we're good. All right, so converse of the Pythagorean theorem. So converse meaning backward, like I said before. So if I have 6 plus 5 equals 11, okay, then I can say 11 equals, or 5 plus 6, yeah. But yes, 6 plus 5 works too. Okay, it's just like mirrored. So the converse of the Pythagorean theorem is if a squared plus b squared that equals c squared, then you have a right triangle where c is the longest side. Okay, your hypotenuse is always going to be your longest side, so c will be our longest side. So today we're going to use the converse of the Pythagorean theorem to classify triangles. Okay, so we're going to either say it's a right triangle, an acute triangle, or an obtuse triangle. Okay, so a right triangle, you'll have one 90-degree angle, right? Right triangle, one 90-degree angle. In an acute triangle, all of your angles are less than 90 degrees. Okay? And in an obtuse triangle, all of your angles, well, one angle, not all, my bad. One angle is greater than 90 degrees. Okay? So one angle greater than 90 degrees. So to see that, I can use the Pythagorean theorem. So with a right triangle, you're going to have those equal, just like we were using before. Okay? So your c squared value will be equal to a squared plus b squared. Where c, you're going to want to say is the hypotenuse, but it's the longest side. Okay? So your c side will be your longest side. In an acute triangle, c squared will be less than a squared plus b squared. Okay? Where again, c is the longest side. Okay, so you take your longest side. If that is less than your other two sides squared and added together, it's an acute triangle. And for obtuse, if c squared is greater than a squared plus b squared, you'll have an obtuse triangle. Okay, and again, c will have to be that longest side. So when we go through these problems, you will want to pick out that largest number for your c value, okay? And you'll want to put it on that left-hand side and set it up exactly like these are set up so you can see what happens to those numbers, okay? So I think this will make a little more sense when we do some examples at the bottom. So we want to classify each triangle as acute, right, or obtuse. So we're given a set of numbers. Those are your three sides of your triangle, okay? My first step, what I do is I pick out the largest number for your longest side. So that would be 16, okay? It's your largest number, so it's your c value, okay? So I can label that as c if I need to. That means the other two lengths are going to be a and b. Okay, so if you need to label a and b, you can. Need to. So I'm going to set it up kind of like the equations were up here. Okay, but I'm not going to put equal, less than, or greater than within the equation. Okay, so I'm going to put my c squared value on the left, which is 16. I'm going to move up here. Now instead of an equal sign, I'm going to put this like blank space. Okay? Then I'm going to add in my a value, which is 7 squared, plus b is 14 squared. Okay, now I just want to simplify down. Okay, so 16 squared is 256. Again, I'm going to just add in that blank space. 7 squared is 49, plus 14 squared is 196. Okay, now I want to combine those two numbers. So I still have this 256 and my blank space there. When I add those two together, I get 245. Now what I want to do is compare those two numbers. Which one is greater than the other? Well, 256 is greater than 245, right? So I'm going to put my greater than symbol here. And then when I look up to my equations, I want to look for these symbols. And since I wrote a greater than, it's obtuse. So I can write that this is an obtuse triangle, and I'm just going to use the triangle symbol. Okay, so it is an obtuse triangle. Questions? All right, I'm going to skip down to number 3 here. Okay, this one has square root symbols, right? So I need to know which one of those is the greatest number. Okay? So if you can't figure it out by looking at it, you can always plug those into your calculator, okay, to see which one is greater. Now, I don't know where my calculator is. I don't want to use my graph. Grab this one. All right. Again, I know it's really hard to see, but I can take the square root of 5. Okay, I get about 2.2. Right? If I take the square root of 12, I get about 3.5. Okay, that's greater so far, right? And then the square root of 13, well, that's 3.6, so that's going to be our greatest one. Now, I don't want you to write the decimal approximation down when you do this process. Okay? So, square root of 13 is my greatest one. That's your C value. The other two will be A and B. And again, I want to set it up so my C squared is on the left-hand side. So I'm going to take the square root of 13 squared. Draw in my blank. Then I have the square root of 5 squared plus the square root of 12 squared. What happens when I square root? They cancel. That's why I didn't want you to write that decimal approximation, because this will make it easier for you. Okay, so that square cancels out your square root. So all I'm left with is 13 compared to 5 plus 12. Okay, so that square cancels out that square root. And then I can combine 5 and 12 to get 17. And then comparing those two numbers, 17 is greater. So we have 13 is less than 17. What type of triangle is this? Acute. Good. Questions on that one? All right, I'm going to go through number 4 then. Okay, again, this one's a little bit different. It has some square roots in it, but it also has constant numbers on the outside of that square root. So just like what I did before with these ones, I'm going to type them into my calculator, okay, to see which one of those 3 numbers is our greater number. So if I take 2 times the square root of 3, I get about 3.5. Okay, that's 1. If I take 4 times the square root of 4, I get 8. Okay, so that's bigger so far. And then if I take 3 times the square root of 5, well, that's 6.7. So that means that middle number of 8 is my greater. Okay, is that making sense to you guys? You don't want to, again, you don't want to write down that decimal approximation for these ones either. All right, so since 4 times the square root of 4 is the greatest, that's your C value, it's your largest side. Then we have A and B. And again, C goes on that left-hand side. So we have 4 square roots of 4 squared. Again, draw in that blank space. We'll have 2 square roots of 3 squared plus 3 square roots of 5 squared. Now when you have something like this, yes, your square root is going to cancel because of that squared, okay? But you also need to apply that square to the number outside of that root, okay? You have to distribute it to both of those terms, okay? So I have 4 squared is 16 times the square root of 4 squared is just 4, right? Draw in my blank space. Again, distribute your squares. So I have 2 squared. That's 4. Then I have the square root of 3 squared is 3. Plus, distribute, we have 3 squared is 9. Times square root of 5 squared is 5, because that square root cancels. Are you with me on that part? Yeah? Okay. So now I can multiply these. We have 16 times 4 is 64. Blank. 4 times 3, 12. Plus 9 times 5 is 45. Add those together. So I have 64 compared to 57. And 64 is greater. So this is an obtuse triangle. Questions? Okay. On the back. Yeah, I just skipped one. It's okay. Number 5. We want to find the value of x and we want to show our work. Okay, this is what we did yesterday on our assignment. You're just using the Pythagorean theorem to solve for x. Okay, so it is opposite that 90-degree angle. So it's the hypotenuse. It's C. That means the other two sides are A and B. Okay, so keeping up with writing C on the left, I'm just going to do it that way. So we can have x squared is equal to, and yes, this is a right triangle, so I can say equal to because of that 90-degree angle there. 16 squared plus 33 squared. Okay, just simplifying, we'll take 16 squared is 256 plus 33 squared is 1089. Combine the two, we have x squared is equal to 1345. Take the square root of both sides of that equation, and x will be about 36.7. So that's just kind of a review of what we worked on yesterday in that assignment. Okay, we're still just using the Pythagorean theorem for that one. Questions? Most of you did pretty well yesterday on that assignment. So, number 6, we want to decide whether or not triangle PQR is a right triangle. Okay, yes, it looks like it is, but we want to see if it actually is. So, first, I want to see which side is my longest side. Okay? Yes, 20 is your longest side. Okay? If I were to enter 10 times the square root of 3, it would be less than 20. Okay? So this is going to be your longest side. And I can label the other two sides as A and B. So we want to do what we did on the front. Okay? We want to compare our longest side to the squares added together of your two other sides. So we'll take 20 squared and compare it to 10 squared plus 10 square root of 3 squared. Okay? Because we want to see if it's actually a right triangle. So now I can take 20 squared. That's 400. Compared to 10 squared is 100. Plus, again, distribute that square to both terms. So we have 10 squared is 100 times square root of 3 squared is 3. So we have 400 compared to 100 plus 300. So 400 compared to 400. So yes, those are equal. So yes, it is a right triangle. Questions on that one? All right, so for sake of time, so I can have you start working on your assignment, I want to skip down to number 8. Okay, number 8 is a little bit challenging. So it's what we did yesterday. Okay, what we did yesterday, we're already given, it is a right triangle. Okay, that's what that box means. So to find x, I can use the Pythagorean theorem. So opposite that 90-degree angle is your hypotenuse, C. The other two sides are your legs, A and B. So again, I can use A squared plus B squared equals C squared. Do you want me to write C first? Yeah? Okay. So since C is x, I'll write x squared is equal to A squared. You need that whole quantity of x minus 3 squared. Okay? Plus B is 9 squared. Now here's your difference with distributing squares. Okay, we distributed our square up in this problem, right? To both of those terms. Yep. What's different about this problem here? There's no square root. What else? Yep. There's a variable. Anything else? There's a negative sign? Yep. There's a subtraction sign. So yes, there's a negative sign, but there's a subtraction symbol right here. These two are multiplied together. Okay? Since these two are multiplied together, I can distribute my square. But since there is addition or subtraction in this one, you cannot distribute your square. Okay? What this actually means, if I write it off to the side here, x minus 3 times x minus 3. Bring back some algebra here. How do I solve this? FOIL. Okay? So first, outer, inner, last. Okay? So multiply together your two first terms. So x times x is x squared. X times negative 3 will have minus 3x, right? Same thing here, inner. Negative 3 times x, minus 3x. Then your last terms, we have negative 3 times negative 3. So positive 9. You with me on that? Awesome. So we have x squared minus 6x plus 9. Now I want to bring that back over here. So I just simplified this piece. So I still have x squared is equal to, I can write what I just found in. We have x squared minus 6x plus 9. Okay? Then I have to add on that 9 squared, right? So plus 81. First thing that I'm going to do, I'm going to subtract x squared from both sides of my equation. What happens? They cancel out. Okay, so now over on this side I have a 0 equals, I still have this minus 6x plus, can I combine these or do you want me to not combine those right away? Okay, plus 90. Okay, now I need x on one side, so we'll add 6x to both sides here. So I end up with 6x equals 90. Divide by 6. And x will be equal to 15. Okay, I wanted to do this problem because I know you have one on your assignment like this. Okay, so if you see that quantity, okay, that quantity squared, you need to go off to the side here. You need to FOIL it out. Okay? And I believe on your assignment, your x squareds will cancel just like they did in this one. Okay? Questions on number 8. Are we feeling okay about this? Yeah? For sure? Does everybody have one?
No, I did not. Sorry.
Oh, it's okay.
I missed the last one. So is it like a polynomial? Yeah, see, LaShawn doesn't have this. Oh, maybe he does.
You don't need to bring all your stuff. Put it down. You just need your binder, the note sheet, assignment and a pencil and calculator. Bring your calculator. Thank you. A calculator?
Yeah.
Sean, do you need one?
Oh.
There you go. There you go. You want to help me now?
Everybody else was yeah, just do you.
Okay, so let's go.
Yeah. So first you want to tell me which one of those is the longest step.
Are you sure they're naturally just like that?
So that's your first step.
And read the eye thing.
Yep.
Not all of us have pretty eyes. No. Do not do that. It's like your feelings. That's American. She's American.
Well, maybe.
I swear to God. Stop. Stop. You're actually gonna drop it. Drop my glasses when you don't do that. Hey, oh yeah, she called. Wow. Really? I wanted to try it, okay? Urban State is not really good.
Oh.
Right. I like this. I have this so old. I should have this is really old. Very good. You would guess how old it is. 2007. Oh, 1990s. No, it's not that old. My mom still doesn't make it. That was just you know, we're just talking about makeup and how my mom like those are my well, like practice. No, it's like it's still like how are we? It's like that's so I'm really sure. Probably like just I'm trying to milk it. Like it's so